Again, whether your system is DC or standalone, your habits control your consumption.
I agree. It's not more.
So-
It's the concept. We go back and we go here to the concept of providing thermal comfort. By putting temperature 18 degrees, which is here in this area, are we working on the right thermal comfort and so on inside the system? I'm not
Okay,
taking the
let's
time.
just go back to examining the witness. Yeah.
Hold on. No. I don't want to give my arms like easily. I want to close the loop here. To make we addressed that standalone system as is providing less risk compared to another system, because we're talking about also longitudinal system. We talk about commission and the timing, and I guess the witness is for you now. Thank you so much.
All right, thanks. So you said you got 8,000 cubic meters, and that exists inside the district cooling plant, correct?
Yes, that is for the first flush. When you flush your system, you want to
Okay,
dump the water.
and you say 5 months, and you know,
Yeah, around 5 months. If we use an optimized filter system, if you want to go for a bigger filter, you need
Okay, so
to
what-
pay a bit higher amount of
you-
money and reduce that duration.
okay, so I want you to tell everybody that it has to do with what filters you use, how many filters you use, right? 5
Yeah.
months is, 400, let's say it's 400 cubic meters an hour. 24 hours, you're done with a cycle.
Yeah.
So
Again,
5 days,
please.
you've done 5 cycles. You can get rid of a lot of iron in that time. And I need to know, what's the health risk for iron?
What's
No,
the health
tell me.
impact of iron?
Huh?
Yeah, iron.
Yeah.
If you dump it to the landfill and the plants took
And
it,
what happens?
it causes cancer.
Cause cancer!
Yeah, what is
Where are you from?
Jordan?
Where I come from, we drink rusty water. We drink rusty water.
No,
Sorry, the benchmark is the international laws on health and safety. We are not
Except
creating
that
here.
there is-
We are not creating. We are
It tastes
referring to some.
bad. We agree, it tastes bad. It may be cause
Yeah, okay, you're
you
allowed
some
to-
indigestion, and it may even cause you some
yeah,
kind of issues for
potable
the
water
waste
has
system.
an amount of iron, but not.
The presence of iron and magnesium in water is not considered health problem. In fact, small concentration are essential to human health. However, high concentration of iron may give the water an unpleasant
Taste.
metallic taste while still being safe to drink. And water, iron exists.
Yeah, okay, but we are talking about the humans. But what about if you dump the water to the sea? What's gonna happen?
Well,
to
the sea
fish?
doesn't care more.
We don't have information actually.
The sea doesn't complain at all.
Objection,
I
objection.
promise.
Did you, because when you commission it, it's a black water. Did you witness, I'm asking specialists
no,
here.
wait.
It's a black water. When
Let's
you
go
take
back.
it, it's black water.
He said 20 parts per, right? You said 20 milligrams.
milligrams.
Okay, so that's not black water. Man.
No, when you commission first round,
He,
Well, I'm
he
asking-
made a statement.
Yes, 20 milligrams of
First, I'm
Fe,
saying
of
first
Fe.
You-
I'm not
he
talking
made the
about
statement, not me.
TSS.
no,
Okay.
I'm asking the
And then he
first
makes
round.
statement. Now, he makes statements about when bad guys dump water to the sea. Come on, where is that going on?
Yeah, but we are talking about environmental impacts now.
If you're seeing that and you're not turning them in, then you're the bad guy.
Why I should be the bad guy? That should be treated actually. If
Oh,
you have-
okay,
if you
so-
have- no, but
No.
if you get back.
There are places to turn this in. Okay, so you talk about some people skip treatment.
Yes.
What people? What, I mean, saying statements like this.
Real.
Yeah,
That's
the-
about the real case.
You know,
in those plants built out, how many of them they have filtered all this water? When you flush your system, you have a big system of the sea cooling, long pipes, etc.
That's why I think it's
You
why
have a
it's
large amount
not
of
cheap.
water. So who's filtrating that one? At least one or two.
You know,
passes.
these people in district cooling have too much water to just truck it somewhere, right?
Yeah, okay, but
And they're not by the sea,
No,
so you
look-
can't dump it to the sea.
I'm just talking from an environmental point of views. It's a rules
But
here and
that's
there.
it,
And
okay?
I think
And I
UAE here
can
they are
say
building some.
that if you outside here, when you take off with your spaceship and it goes up, you're gonna cause some issues here, but we got no spaceship. These people build plants inside cities. We just don't run a hose over to the sea.
Of course, yeah, we came up with this comment actually just to know whether there is a real regulation here or consultants just give some ideas about filtration,
Okay,
whether
but-
it should be
but
filtered
that's
or
not how you
That's
presented
what
it.
we need to point out. I'm
My
not telling
friend, you
that
presented
need-
it saying the bad guys are doing this.
I didn't say the bad guys doing that, but I'm
Okay,
saying
let
that
me
this
rephrase
is,
it. You said the
this is
people who dump it to the sea are doing bad.
environmentally harmful. Since it's not harmful,
All right.
then nobody will make it as a rule.
Okay, so let me ask you this question. So how many of these people have you seen dumping to the sea? How many of these people have you seen who are not putting the treatment systems
I
in
didn't
district?
see anybody, but I'm now talking about a real case. I'm working with the consultant right
so-
now. He wants to dump
so-
the water to the sea.
All right.
And
So
he
let me
has,
re-
he has
let
a
me-
concern about
You'll have him
environment.
back. So if we don't dump this water to the sea, we clean it up, and if we put the equipment
No,
in
but
to
what
treat
about
the
the
water.
landfill? What about the landfill also? We need
I'm
to study the
asking
impact
questions,
of the
you're
landfill.
answering questions, okay? I want an answer that says, if we don't dump to the sea, then no issue, correct?
Oh, but where you dump it? Yeah, if you do dump it in the sea, okay, there
We
is no
don't- we
issue.
don't dump it.
But what about the landfill? Where you dump your
We're
flush
dumping
water?
the iron that is collected, agreed, but we're not dumping the water. Water's too precious here to dump, by the way.
No, where you dump it to the sewer?
No, we don't
exactly.
dump at all.
You use it again in the system for the flush water?
We first flush, and we filter, and we take out the
Yeah,
iron.
that's very good application. Okay, I'm talking about the people who dumps that water to
Okay,
landfill.
we're
or to
talking
the
about
sea.
district cooling plants. These people don't do this, okay? Okay, and then I need to know, if we put in the right chemical treatment so that we don't get Legionella and some of these other things, no different than a swimming pool, correct?
Objection.
If you,
Do we have we have cases, documented cases, but that in England only about 100% a year died by Legionella. It's in the Sepsi magazine.
My friend, I was in Indianapolis, Indiana, the day that they had this mysterious
this
disease
is in
that
the
no one
cooling
knew what it was. It was later called Legionella. I know what it is.
Mike,
But
Can I
but a
just-
swimming pool could have Legionella if you don't treat it right.
can I just comment on that now? Are we talking safeguarding the environment per incident, or it's a rate that is continuous? This is a big difference. How many times the 8,000 cubic meter is going to be done in the life of the system? This is number one. How many tons this 8,000 ton equates to in refrigeration compared, just let me just do this. I fire a question and I do not answer. It's enlightening. How many tons this? And if you want to break it down to the size of the small DX units, how many units it is going to compare with? And
We will come to that. We will come to
No, no,
that.
the most important issue is the incident is not what you safeguard the environment by.
True.
It's the rate continuously per hour or per day. We have a tsunami in Japan, very recently. Did it affect the environment? Yes, but is it going to continue? It's a rate. This water, if it is going to be done one time and you divide it per unit
True.
of time and per ton, it is almost nothing. It's like you cutting your finger
We need to go.
and you close it. We close.
Your Honor,
No, we close
we are
now
going too
because
much on,
It's lunch hour. It's lunch hour. It's not his time now.
no, it's okay.
No, we
You
want
need-
one witness.
You need both of you to agree, are we talking per incident or it's a continuous effect?
Per incidents. Per incidents, he said that we
incident-
will tackle that.
But incident,
And-
it doesn't,
No. His case is per incident. When we tackle refrigerant and we recover global warming, it will be continuous.
to continue. So
But-
incident doesn't count for safeguarding the environment.
I'm glad that this is the best that
It's
our
not-
advocate came up with. I
It-
mean, it's
the
a weak
approach.
case. It's a weak case. What we are saying. If this is a concern, the environmental concern, that's great. I mean, we are able to deal with it.
Yeah.
But
Approach, which is the approach.
Exactly.
The way we approach the issue.
Yes.
sir, we will tackle that.
Just in 10 seconds, I mean, I mean, I'm here as a witness, so I'm just delivering some cases to the consultants like you, like everybody, to...
against you.
No, I know that. No, it's okay. I know that we are here. It's,
No, we appreciate what you brought
I
forward.
thank you really
but
very much
the-
for all your comments, but
they are-
my message to the consultants that...
As you said,
we
there
need
are
you
ways to
study
deal with it.
also. We need
Fine,
you to study
fine.
the environmental impact.
Yeah,
of
okay,
all
okay,
that
I
water.
think order,
If it's
please.
needed to be treated, then it has to be a rule for treatment. Otherwise, it hasn't to be. But it's a point that has to be put in the table.
Yeah, it's fine. Thank you very much. I think we've killed this this debate, this witness with questions, and I'm sure the point is came across clearly, and we both examined you. Thank you very much.
Thank you.
Thank
We are gonna extend our time till 1:45. That's
Quickly,
okay.
Matthew,
I will have one witness from your side, George. Thank you.
Matthew, please. Matthew Plumridge is a consultant of environmental and sustainability planning in Department of Municipal Affairs in Abu Dhabi. Matthew, you probably I'm gonna ask you about exactly what Mr. Ghalib has said. From global warming potential, from refrigerant issues, the Gulf states combined consume more refrigerants than the entire continent of Africa. And the Gulf countries have signed to reduce 15% of the refrigerant import by 2012, and they need to submit a plan before end of 2011. Now we know district cooling has all refrigerant leak detection, has pump out unit to pump out the refrigerant, yet on standalone system we have no regulation for technician to go, and they even flush the drainage with refrigerant. Any problem they happen, they leak the refrigerant to the atmosphere, and we don't have local laws to penalize them. What is Abu Dhabi municipality will do for these? Again, I don't want to stamp all the standalone with that, or even in district cooling. Both parties can leak refrigerant. What are the local laws that will prevent anybody of releasing refrigerant to the atmosphere?
Okay, well, there are a number of agencies involved in the municipal system, essentially. The stakeholders would be the Department of Municipal Affairs and the municipalities, and also the Environment Agency and the EHS Centre. Now, there are codes of practice that relate to EH&S, not only during construction, but in operation per sector. So essentially, speak up more? Okay. So essentially, in that, every sector will be governed by, that has a facility in operation, will have an environmental health and safety system in place that is readily audited. Coupled with that, the DMA is putting out new regulations that relate to property maintenance, which again will be another level of comfort to the industry that won't happen. And of course, you've got the Environment Agency, which is the watchdog as well. So there are multiple entities in place to enforce and police that.
When do you expect a change in habits to happen?
With the release of the new building codes, essentially, because they are an integrated set of codes that not only relate to property maintenance, but also the energy efficiency of systems and the types of refrigerant, which are actually covered in the mechanical code. So there are banned refrigerants in there. So essentially, it's a phased approach, and we are giving a grace period to industry, but at a certain point in time, we're going to say the grace period is up and they're fully enforceable. And we're looking more at the second half.
So you're going to restrict the R22, you're going to restrict the R123?
Absolutely, yeah.
And this,
actually, there is another level. In fact, it's almost a supersaturation of programs. There's the Estadama building rating system, which couples with the mechanical code, which regulates all new buildings and the types of refrigerant to be used there. There's also another program coming out for existing buildings.
wouldn't you know, I did a study and found that per ton of refrigerant, you have stand-alone in district cooling almost the same amount, 0.5 kilogram of refrigerant per ton. But I found that because we have less ton in district cooling, we have the means, it's easier to manage, easier to maintain, and easier to inspect from authorities rather than hundreds of small systems. Would you agree with that?
Absolutely. The one pitfall of the electromechanical industry here is the lack of appropriate maintenance, not only personnel but societies to ensure quality. Centralising a refrigerant or use or any other dangerous, hazardous use of material is the right way to go, I believe, until such time as industry is equipped to be able to send out personnel to adequately maintain and regas and drain systems, then best centralise it. Also, in part, it's the demographic. There's a transient nature of personnel here, where vital knowledge often leaves, and then a reschooling goes on, and that, when it comes to dangerous substances, is something that we can't let happen too often.
I will come to the efficiency now and the power consumption and impact on global warming and CO2 emissions. In a central plant, we monitor on hourly, daily, and monthly basis, and the trend, for example, that kilowatt per ton in district cooling is reducing per ton by fine-tuning, by the operator is improving. And we notice in standalone system, no measurement whatsoever, or very little measurement is happening. And even when the condenser coil get eroded or dusted, or equipment are not well maintained. So, I mean, the theoretical data that even it is 1.5 time consumption of power become 2 time and 2.5 time. Would you agree that also central plant are easier to monitor and they play a major role in cutting emissions?
Indeed. A central plant, essentially the business is to optimise their system. It makes business sense. In the standalone world, we're finding out, the data shows that systems are left to become dilapidated. A recent study by the Executive Affairs Authority, some 6 months in study, has revealed the poor nature of maintenance, because there is no business case when tariffs are so low to maintain efficient plant equipment.
And in the Vision Urban Plan Council, or how important is to encourage district cooling in the city of Abu Dhabi?
Well, look, district cooling is not the panacea for everything. It's a function of density, but it's also a function of proper regulations and proper business model for return on investment. So I think the district cooling industry has done itself a sincere disservice in that the recovery of funds has been far too aggressive, and what it's done is essentially, it is a utility. When you price a utility, your return on investment should be spread out over 10 to 15 years.
But Matthew, our knowledge that the Urban Planning Council, when he puts a 2030 plan, they considered part of their emission model that there is a major part that will be covered by district cooling.
Well, look, it's a function of density, because first of all, when the economics are correct, is at a floor area ratio of 2.1 and above. Less than that, it doesn't make sense, and there are a number of examples of its failure there. After 2.1, it is viable, but it then has to be economically viable. And that's really is.
And you are saying that 2.1 is a 2.1 square meter of built-up area per square meter of plot.
Indeed. Yeah.
This is
essentially, yeah, precisely. It's a
just
function of density, yeah.
to explain it to the jury, and please, it's your witness.
Hi, Matthew. We don't argue that centralised management of refrigerant can be far more efficient than decentralised. If you've got lots of units, you've got a lot more joints, you've got a lot more risk. So for sure, it's difficult to argue against it, and I won't even attempt to argue against refrigerant loss at all. But if district cooling was more attractive, as you mentioned, in terms of tariffs and that, people would go more towards it, and then we wouldn't have such a loss of refrigerant. So, as you said, it's doing itself a disservice. But within the district cooling industry, they're still using R123 which in Europe is already banned, and it will be banned in here eventually. I mean, I presume we're following is it Article 5 of the protocols, is it, for in terms of its reduction eventually? So it will happen eventually. It will be phased out. The 134A isn't used that often in Europe now, so we are behind here for sure. 123 is used in all sorts of applications, cars, propellants for aerosols and things.
We object for that. Even R134A is subject for phasing and has been phased out from several countries in Europe.
Yeah, that's what I mean.
And I mean, now we see a trend toward natural refrigerants such as ammonia, such as CO2,
Yeah.
and such as methane gas.
Yeah,
But again, R123 is allowed in Montreal Protocol, which we signed for up to 2030 in this country.
Because we're in
And
Article 5.
we are not violating this recooling by using R123. We are not violating the Montreal Protocol or the restriction on its use. And we think that the leak rate is so low, the global warming potential is there, yes, but it's safe, it's much more efficient, and then save continuously on CO2 emission, which come to Mr. Ghalib point, the total impact, environmental impact
Yeah.
of R123 probably is as good, even better than R134A.
Yeah, I am aware that there's less of a load on the power generation side, but the community is banning it, and that's it. So it will go eventually. Yeah, okay. Yeah, no, but we go, but we're now in, what, 2011? The plant's going to run 30 odd years. So I'm just saying it's looking ahead for the future, that's all I'm saying in terms of R123. It is a refrigerant that has a definite end. 134A will continue beyond that at the moment, that's all. So in terms of the refrigerant, then we need to sort of look at it. We know it is more efficient in terms of that, and there's very little alternatives in the unitary products.
Can I argue also that standalone, more than 50-60% is still using R22
I'm sure.
today? Also, here, in this country, I mean, we still use in standalone system massive amount of R22, and the majority actually.
Yeah, no, I don't argue. I mean, it's because there has been a lack of legislation here. It's not being enforced, which Matthew's now saying that they are starting to do that. So, for sure, we'll pick up on it. But as a region, if you like, it's with air conditioning it's essential. In Europe, you can get away without it. I mean, we need it here. We can't get away with it, and so it's always going to be a problem. It's just a question of how we manage it. That's all. But difficult to argue against you. I mean, yeah, refrigerant is a problem. Yeah.
Okay. Yeah, well, you spent like what, 10 minutes in not a question? We need a question with a very direct answer, otherwise
No, with
we'll have very starving people hate you.
No, we are it's going to be very quick. Matthew, here in Abu Dhabi, coming back to Abu Dhabi after 6 months, I find it's a nice city. One of the questions, if I have a building in Abu Dhabi here, and I build up something on the Corniche, for example, and somehow the owner is pushed to go for a standalone system, either air-cooled or water-cooled, and he has to do with that, knowing that the regulation is going to come up with the new level of efficiency. Regardless, you're going to go standalone system or district cooling, whatever. And some people, they went for air-cooled for other reasons, for space, because they couldn't put anything. I think the question is for the municipality. It means I think the two solutions are there on the table. Either district cooling system, as long as we have that network, that corridor service, it needs a lot of things, or standalone system. Now, from municipality, what are the current constraint in hurting the district cooling approach, networking, to grow and have more penetration on the market?
Okay. Well, really we have to define it in terms of new build or existing build. Now, if we're doing an existing building in on the Corniche, let's say, well, we've obviously got a number of constraints. Traditionally, district cooling pipes would be in the road. Now, if we were to dig up the road, we would have real traffic issues. We've got examples of Al Salam Street, which shows how paralysing that kind of exercise would be. So more than likely, district cooling will have traction in the new developments, simply because you can plan it properly.
Thank you very much. Thank you, Matthew. We'll be breaking for lunch now. Unfortunately, we'll have a kind of a short lunch break, so we'll convene back here at 2 o'clock. That's fine? Sorry? 2 o'clock. Sorry, I meant 2:30 as the schedule. I didn't mean 3 o'clock, sorry. Is he in?
Yes, Prashant, quickly. On the way, we're going to ask you. Refrigerant issues and impact on the environment, management of refrigerant of district cooling comparison with standalone, and efficiency of systems and impact of global warming of both systems. Aren't we, how do you think we compare? If you consider refrigerant, type of refrigerant, environmental friendliness, and control of refrigerant leakage, and management of refrigerant, how does standalone compare to district cooling?
I think so. You touched base on that subject, and I'm going to reiterate on that. There's no regulation as part of the emissions is concerned by leak rates are concerned. There's no regulations as part in the UAE at all, or probably in the Gulf region.
The only measurement is how much we import.
Exactly. Yes, that is the only way you can look at it. But responsible companies like Carrier, I mean, we as a United Technologies carrier, we have a EH&S policy that we try to, within our limited resources, what we try to do is we educate our technicians, we try to limit not to do what is bad for the environment. So as a responsible company, as a corporate responsibility, we do take care of those things. But beyond that, if a layman is maintaining a system, and that's what 90% of the cases are, that our involvement after the sale is done or after the job is finished becomes less, and then the private people try to come in. That's when the whole thing changes over, and then people do it. The worst case. Yeah.
On the blowdown of water and impact on environment, do you think really the blowdown from district cooling can be properly managed, can properly be reused in irrigation or via dechlorinification and RO be recycled like Emicool has been done? Do you see any big issues there?
Well, I mean, I was listening to on the side of it when the discussion came up. It was very sad to note that the district cooling industry is in that business. No, to be clear, most of the district cooling companies don't do that. They are responsible companies. Mm-hmm. They do try to take care of their water treatments, and then in fact, the district cooling industry encourages using recycling water in TSC, for example. That has been forthcoming. It is very, very important that this aspect is never brought up here. This is one forum I would like to bring it up.
So far, in operating more than 2 million tons of district cooling in UAE, we haven't any recorded Legionella cases. Yet in one of the hotels in Dubai, we have a suspicion Legionella cases in standalone. How do you see also controlling Legionella on a central plant with much higher level technician? Isn't it much better controlled than smaller water-cooled standalone system?
Definitely, because I'm pretty sure most of the district cooling companies, have water treatment specialists under their umbrella, and then they do. The regional, especially, is a major concern for all these companies, and they take care of it in a much better way than an individual owner representing a building, for example.
The case is recorded in London. It has standalone in the hospital. The case recorded in Malaysia, it was a standalone in a mall. and majority of the Legionella cases in the world were linked to standalone system.
I'm not aware of those cases, but yes, it is a concern, and it is very well accepted in the district cooling industry that this should be avoided, and then they take care of it. Very
Thank
clear.
you.
George, can I go a little further?
Yeah.
By having a permission, I've been listening on this part of the as an audience, and there are several things which, as a responsible citizen, as a responsible person, as an ASHA representative, I would like to bring it across here is, people in this forum, at least I have seen some gentlemen here talking about an individual end user's interest, when it comes to paying money, paying dollars to a ton hour. So I was just trying, while during the lunch also I was trying to talk the same subject. We need to go beyond a commercial interest when we talk about district cooling versus standalone system. Yes, if I am an individual, I have money. Yes, I am a rich man, I have money. I am ready to pay for my own air conditioning cost, my own. But going beyond that, you may have a 3-bedroom villa, no problem. You may have a 5-bedroom villa. But beyond that, there is a national interest which has to be taken care of. And beyond that national interest is the global interest, which is, I'm talking about environmental interest. So we are not focusing on those areas here. We are talking about cost to cost. Yes, when you come to a layman's cost, yes, you might find that a split TC's first cost is lower, but I would like to take this beyond in the discussion that, you need to have that in mind on a national level interest as well as the environmental interest. The second thing which I have noticed is that people talk about, I've noticed that, they talk about, for example, no commercialism. But unfortunately, I've been noticing it that there is a commercialism interest is creeping inside this. For example, they're talking about magnetic and naming companies. See, technology is there across everybody. VRF technology is nothing new for an organization like Carrier. I can talk about it. But I would request that commercialism to be limited at this forum and talk about technology, because that is what is important here. Okay. Please.
Right, so just to answer George on the Legionella about standalone systems, the Legionella is from cooling towers, I assume is what you're saying. But I'm sure Legionella is a lot more widespread here. It's in people's water tanks, on top of their roofs, in their garden sprinklers. It's everywhere, but it's just that either we get lucky and we don't actually catch it, or we're not exposed to it, we don't breathe it in. We may drink it, but we don't get the Legionella that way. So there may be a higher level of O&M on district cooling plants, which may negate that. I don't know district cooling plants actually do much in the way of active Legionella control. They will do it for micro sort of biology control and for scale protection and stuff like that, but I don't know if they do anything on actually Legionella. They do chlorination, which is mainly to kill the bacteria. Yeah, but not active. It's not continuous. They'll go and take samples.
Every day.
Yeah, every day. Okay, but yeah. So there may be a bit more risk, but we are in the Middle East, and the temperatures are ideal for propagation of Legionella. It's just where we are. So it's just one of those things we have to face up to. So basically, we have what we have.
I like to chat with you and comment if you don't mind on the...
Yeah, we don't have much time. Yeah, I think we will leave this off after the sessions. We can talk about these things. I appreciate your comments, but we have a set agenda that we need to be in line with. Thank you very much. Jury, any comments? Okay, thank you very much. I think it's time now to move for our next topic, which is water and its availability.
Still one more.
Sorry, I'm sorry.
No, not you. Albert, please. We're going to go with Mr. Albert Heikel, who is ME Regional Sales Manager at Train. I want to ask you about R123 refrigerant and now, and what is the future plans in the future? You see the new trend in refrigerant, environmentally friendly refrigerant. Particularly, you mentioned one is being developed right away.
we see all the refrigerants which are being used today can be used for time being. But what's going on is every refrigerant we are using, it has issues with the environment, either ODP or GWP or efficiency. Now, there is a trend which is happening now. There is development of new refrigerant, including going back to natural refrigerant, which is ammonia, and in some aspects CO2. We see a new series of refrigerant which is called HFOs, hydrofluoroolefins. The first of the refrigerants is already developed. HF01234YF is being used in the cars. Chrysler, Mercedes, BMW, they decided to phase out 134A and to go for that. Now, what we see happening by 2015, most of the refrigerant we see today, including HFCs, 410A, which is used in unitary, of course, HCFC 22, HFC 134A, and 123 will start being reduced in use, and you'll see one of the HFOs will replace it. There is high pressure HFO, medium pressure, and low pressure. And in fact, the problem with high pressure HFCs is they are very high in global warming, and they are one of the high hit on the list. They have a 1600, even the new one, which is the 410A, is now being introduced in UAE. It has big problem. It's already phased out in Europe. It has a lot of issues with that. So the future is for HFOs, what we see today. And the HFOs, the special thing about them, they have a dual link, which if they are released to the atmosphere, they will disintegrate, and they have a life of few days, 15 days, 20 days.
Albert, do you think these can replace existing refrigerant and existing equipment, or they have to be used with new equipment only?
What we see today is there might be possibility of replacement of retrofit of existing equipment into new with a new refrigerant. But what we see is the most important today is the efficiency. Efficiency will affect the global warming indirectly because you are burning a lot of CO2 to do that. And if you lose 5%, it's a huge effect on the environment.
So are these HFOs more efficient than existing refrigerant or slightly less efficient?
So far they are working on efficiency. They are not as yet as efficient. But what we are saying is if there is be retrofit, you lose a lot on your efficiency of the existing equipment. And we believe that keeping the machinery that you have responsibly, keeping them under well control, the most important is to keep the refrigerant inside the units. If the refrigerant is inside the whatever is it unitary or applied or district cooling, if you keep them inside the equipment, there'll be no problem of emissions, of direct emissions.
One aspect is, of course, the environment, but we have also safety issues.
Yeah.
I mean, we know that some refrigerant has exposure limit of 50 parts per million, some refrigerant 1,000 parts per million, and we know that even in some of the manufacturing factory, big explosion happen due to mismanagement of refrigerant or the mixture with oxygen with refrigerant. So there are hazards and there are safety issues with refrigerant. Though we don't have exposure cases here in UAE, but from your perspective, will the new refrigerant be safer and will have higher level of exposure to human beings?
This is an important part because when they were searching for new refrigerant, one part of it is flammability, toxicity. So now these are all taken into consideration because they already have a refrigerant which is flammable, but it's efficient and it was good, but they could not use it except in a secondary circuit because it can explode. Now going back to the safety issues on refrigerant if you, and district cooling, if you use it properly in a plant room and well controlled, you have an advantage. While if it is dispersed to many units around in the area, or if you have small plant rooms, even water cooled, they are not as controlled as the main plant room of district cooling. And you might have a refrigerant loss, which happened. One is in Alaska, and there was 7 people injured, but it was HCFC 22. It's high pressure refrigerant. Now, if you go to low pressure,
What is the case? Sorry, what is the case in
it's
Alaska?
an ice rink.
Yes.
Where there was a rupture in a pipe. It was R22, and 7 people are injured on that
Ice rink.
On the plant room. Yes, in the plant room of the ice rink. And so basically, the advantage if you use low pressure is that the refrigerant will not go fast. It's safer. So if you have medium pressure, is better than high pressure, but the worst is high pressure.
We are done. We leave it to you guys.
No questions? Jury? Thank you.
Thank you very much. I think we are ready for the next topic. Can standalone systems please invite their first witness?
We call upon Francois Loueri. No, we've got others. We have got a big queue outside there, but there's too many to come in the room.
I just need power. I just need a power plug. Not to lose my...
Ah, you got a...
It's okay, maybe there's enough. It's okay. Prashant, we're not in the business of water, but I'm going to talk about water conservation. And I was wondering about technologies that exist among all the big companies, so I wasn't specific about any brand earlier. I worked 3 years in the water, on-site water treatment before rejoining the HVAC industry, so this is where I wanted today to contribute water treatment system on a small scale versus bigger scale. If this is okay with the jury and with the...
Yeah, that's what we invite you to do, to look at water treatment within standalone applications where you can recycle on site. Yeah.
Okay, the MENA region, as you know, as most of you know, is very water distressed. That's what's the definition on a world scale. Just for comparison purposes, in Canada, the per capita water renewable resource is about 98,000 meter cube per head. Okay, in Europe it's 9,300 meter cube per head, per capita that is. MENA in general is 1,418, GCC 141 meter cube per head. Okay. A country is considered to be in water distress when it's below 1,500 meter cube per head. That means unless we are able to generate water with desalination systems, we will have serious problems. So water is the next big problem to solve. And what do we... Today in the Middle East we have 2 regions, and in discussing with solutions we have to keep in mind we have rich countries and poorer countries in terms of infrastructure, that is. The GCC is a region with very big infrastructure ability to invest, but we also have non-GCC countries like Algeria, Egypt, Iraq, Iran, Lebanon. Lebanon is not rich with water, it's reducing, they think it is. Also, these countries don't have these sewer system. For big plants, you need sewer systems in place, and you need major investments. Okay, what do you do? Saudi Arabia, for example, 20% only is connected to sewers. Saudi Arabia, 80% is on-site problems. Here, even in the UAE, we see a lot of these trucks driving away from Jabal Ali, from Al Quoz area, to take these wasted water into a big plant that will treat it and ship it back, and then we all drive and smell the irrigation, the foul odor because of high BOD in the system. So water is an issue, we all live around it. It's very good when it's treated, when it's used for district cooling. Sewage treated district cooling is perfect. But does it make sense to desalinate only for district cooling? That's a question to ask. So on the on-site system, let's say a building that is in the middle of nowhere, not connected to sewers, do we waste the water? We don't have to waste the water. Today you have systems where you put, if you all know in the US, you have 80% of the US is an on-site treatment. So each house will have a leach field, a drainage system, and they bring back the water back into the water table, cleaned enough to go back into the ecosystem. Today, there are technology in Japan, in Germany, in Denmark, also in some parts of the US, where they are recreating that leach field environment in a box. Okay, so they simulate nature by forcing air and by putting a habitat for bacteria to grow and self-clean itself. Result is you can get a glass of water after you treat it just by pure biological aeration that would look clear. Not good for drinking, but certainly good for irrigation, and with some treatment for water-cooled systems. So water-cooled can be used on-site, meaning standalone. It's not needing to bring it away. So for hotels, imagine a hotel that has 500 rooms or 200 rooms, 70 liter per room every day is used. That normally gets wasted. And then the hotel buys more fresh water to use, and then use air-cooled system. What if we integrated all this and used water-cooled systems for that hotel? We save on water, we save on energy bills. Thank you.
Within normal sort of building designs, we would encourage sizable buildings to have their own grey water treatment plants on site, so they can recycle water through the grey water treatment. They can then use that water for if it's water-cooled chillers for the make-up water. If it's air-cooled chillers, they can have adiabatic cooling on the condenser air, so you'll save 20% electricity on air-cooled chillers. Or you can use it, if you've got excess, you can use it for car washing, flushing of toilets, but primarily for air conditioning. I mean, it's ideal for any of the water-cooled or air-cooled solutions, which we can do on site.
Yeah, 70% of the water used in the GCC is for, guess what, for irrigation, right? Because of all the trees and all the landscaping we do. So a hotel has many uses for reclaimed water on site. We have to be very careful on where to use the water, depending on its how much tertiary treatment we apply to it, because you don't want microbes in the air. So underground irrigation is one option, but then if you want to put it in the cooling water system, it should be closed or treated enough not to have bacteria issues.
Yeah, the argument here is that standalone systems can be almost self-contained in use of water, so without having to add additional burden onto the municipality systems and water treatment, we can reuse the water, essentially. So we're not adding, we're not stressing existing systems, essentially.
Yeah.
Okay, thank you. George, do you have any questions?
Just in the issue to clarify to the jury, district cooling, whenever it uses fresh water, it uses around 8.5 to 9 liter per ton hour. Now, if we use an RO that is 6 cubic meter, it requires 6 kilowatt per cubic meter, including pumping energy. And that translates to an additional of 0.05 kilowatt per ton on top of the plant consumption to produce the water needed. And still, in the worst case scenario, district cooling is saving a lot of energy on global energy. In terms of capital cost, when we established Tabreed, we did a total infrastructure analysis. We found that a water-cooled system including the investment of sewer and water desalination, distribution, electricity, save compared to standard air-cooled system around 3,000 dirham per ton. If we went to add thermal storage to that and add the use of TSE water and add the use of gas, the saving in infrastructure costs could reach to the government up to 9,000 dirham per ton, which bypass the investment required in district cooling itself. So there are enormous infrastructure saving, even when sewer included. Now, the second issue about water, now all Saudi Arabia is shifting toward TSE, all Dubai is shifting toward TSE. There is a new TSE plant coming in Abu Dhabi here. In Bahrain, we have a couple of plants using seawater, when we get and call some of the witnesses now. So district cooling has a lot of alternative for water sources. But on your comment regarding the water, today we have new technologies emerging called nanotechnology and manipulated osmosis. Today they are consuming 2.5 to 3 kilowatt per cubic meter, half what it used to. Even the traditional RO have put energy recovery on the blowdown and managed to drop the electric consumption down to 4 kilowatt per cubic meter. But one of the nanotechnology, they put 60 centimeter of water, of seawater, and they managed to get clean water, but they used expensive, they lost expensive agent with that. The dream is that, and I think this is what human intelligence was saying, my vision is by 2020 or 2025, it will be more effective, cost effective, and more environmentally friendly to desalinate seawater in all coastal cities in the world as compared to treating contaminated river water. So I see that happening. I see this is where human intelligence has a solution put in place today for water shortage around the world. But unfortunately, global warming, we are failing dramatically. I think we will fail. We are a little bit late. So I don't disagree with you that water equal life and is very important, essential to it. But I think human intelligence will overcome the difficulty via technology and via I've been monitoring this closely. Today, I mean, there is a manipulated osmosis running in Oman that is feeding the cooling tower directly, it seems, and just consuming 2.5 kilowatt per cubic meter. So technology is evolving very fast in favor of water-cooled system, whether TSE or seawater. Thanks, just to clarify to the jury.
Thank you very much. Jury, want to add anything or ask anything?
We did not see the arguments either for or against one or the other on this particular topic.
We are hoping to get that with other. You want to add? Okay.
See, district cooling today makes good sense, but it doesn't have good competition to stay competitive. So the challenge is to make sure that standalones are very efficient systems and then put the pressure on district cooling to also be even more efficient. The standalones today, no regulations, no classifications, so you're competing with very inefficient systems. The point that I was trying to make is water availability is not exclusive to district cooling systems. It is on site, it can be used, it should be used where possible. Because then you have real efficient on-site small systems.
A little bit. We saw the experience in the Reem Island. One of the district cooling provider, when they designed the network in the beginning, they designed for condensate water recovery, which is also a smart solution. Basically, when you dehumidify the air, you will recover that condensate. And after that, it's mandatory by the design guideline that each tenant will send back that water recovery to cooling plant. And they put the money in it. But unfortunately, this is one of the negative points that is going to the industry. We didn't see that experience going to other configuration. We saw it maybe it's on the Rim Island, and that's about it. So the best water that you could generate is the one you save it. So we have to work on optimization of water within the system, like reduce the evaporation rate, find a better way to mix air cooled with water cooled, find a way maybe to use the ground, the standalone, they call it the geothermal standalone system. That's the way. It's tough to use it in this area, but that's the way it is. So we need to push the thinking and getting to that solution. In the meantime, the standalone system is now, because you are having on-site. On-site, it means the hotel is going to recover that water, pour it down instead to send it back, maybe to use it for toilets, whatever. Most appropriate, you use it for irrigation, also for cooling tower, as long as you keep, because you have to be very careful with the quality of water. So that's why we think the district cooling and recovering that water are not succeeding, versus on the standalone system, you can recover the water from the makeup units, you can recover the water from the gray water. Some people, they push the envelope even for the black water if they have the money, and run your standalone more efficient.
We want you to stick to the point. We're running out of time and we still have one witness, please.
Well, I'm sticking to the point. I'm saying standalone system on the integrative can use gray water, condensate water.
Thank you very much. Thanks. George, your...
we call Mr. Antoine Stéphane.
Anton. So in district cooling application, or in any application where we're going to use water-cooled chiller, traditionally we use potable water, water from the utility, correct?
Yes.
But what are our options? What have you seen used so far, and where do you see us going with water?
So mainly we are using potable water now, and it's slowly going to TSE water when it's available and where it's available. And the other options would be seawater, of course, depending on the location of the plant. And of course, RO water combined with seawater, if also is a solution.
So all those are available.
Yeah.
I just want to ask, TSE, how many plants have you been involved with that said they were going to have TSE, and then how many of those plants have TSE?
It's a very good question. All are designed to be operated with TSE, but for the time being, they are using fresh water. Right. When TSE will be available, I don't know.
The oldest plant that used TSE during the beginning, so University, 30,000 tons.
Right.
Yeah.
30 years of operation with TSE.
Yeah, but I'm talking about, you know,
Yeah,
we're always pushed.
The new developments, I mean, they're all designed for TSE because, you know, the limitations in use of...
The one today is Dubai Festival City with TSE.
Yeah.
And Sheikh Zayed Road with the and there are, according to the power and Congress reports, they are converting 5 or 6 plants each.
Okay.
Yes.
Yeah, we're almost done. He doesn't need. I object. No. So what's it?
The
let's say you're going to do
percentage.
for
I mean, 2 plants out of how many? 60.
So the bottom line is we are prepared and are utilizing.
We should move
water,
forward, and we really we're trying to promote the use of seawater in district cooling plants. Now you have advocates and you have the people who are against because of the limitations of seawater in chillers and everything. So, but for cooling towers, we really, I mean, encourage the use of seawater.
All right, thank you. No more questions from me.
Hi, Stefan.
Hi.
No, in terms of TSE for cooling, I mean, there is no TSE around. or insufficient. District cooling, it's supposed to be, potable water is supposed to be banned for district cooling, but
Correct.
because of the district cooling providers' connections with the government, they've got dispensation, so they are getting around it, or they're blending it, but essentially they're using potable quality water, 100% at the moment, because there is no TSE. Also, the quality of TSE is very, it's not defined, certainly in Abu Dhabi, Dubai, it's probably a bit more regular, should we say. But what about, you not mentioned anything on hybrid towers, for instance? Can you?
It's
It's
a good question.
But nothing's been done on that.
Whenever there is the issue of really water saving, we propose also hybrid cooling towers, but that's not the main objective of hybrid cooling towers. I mean, hybrid cooling towers in Europe or USA are used to reduce plume, but you could also save water on that. So this is also a solution, but it's not economical. So we were trying to promote something like air coolers and water cooler and cooling towers in a row, rather than hybrid cooling towers, which should be more economical to save water. But this has not been, done yet.
Yeah, I mean,
And we have excess capacity. We don't need this.
I think this is going to be case by case relevant, because I know that this is not the case for Abu Dhabi, for example. So there is a water scarcity generally in the region, so we need to be careful about that.
Abu Dhabi, if they stop watering these forests in the desert,
Let's just stick to the district cooling and standalone systems. I will discuss deforestation in a different session. Thank you. Thank you very much, sir. Thank you. Your next witness, please. Hey.
Strong point. We call upon Alan Millen. Alan works for Macro.
Thank you. Afternoon.
Alan, we believe you've been doing a study on the use of water for district cooling, on its usage, the productivity of water, how it can, the efficiency of its use. Can you perhaps enlighten us on what your findings are?
Well, we've been looking at more the wastage of water than the actual quantity used, more the wastage of it. I know George just said we use 8.5 litres per tonne hour of cooling for our heat rejection. If we take that as over 30,000 tonnes perhaps on one plant, and then multiply that out by 4,500 hours, it's a phenomenal amount of water each year consumed for just one plant. And yes, we need to do it, but are the district cooling providers wasteful in their use of water? And I have to say, yes, they are. And to just give you a simple example from what we've heard today, we went through the morning session with touching on sub-metering, and then the environmental session, which for some reason water was kept out of. And I have to say, it's the first time I've ever heard George amazed, holding bills and saying he's amazed how much consumption has dropped when people have control of their bill. So if we were to sub-meter everyone, and when I say we, I mean the district cooling providers, that would put control in the hands of the user. We saw this morning the effect that can have on consumption of the cooling. If the cooling demand goes down, the water consumption will go down. I know that not all district cooling providers meter their clients. I, for one, am built on floor area, as are several of the buildings, well, all the buildings in my development. The district cooling provider has a business model. They're going to sell their cooling or sell the chilled water at a certain rate to satisfy that model. I have no incentive to reduce my consumption because I'm not going to save any money from it. We've seen the effect that putting me in control might have, and everybody else on the development. And it seems clear to me that district cooling providers are putting profit before people and planet. If they weren't, they would meter everyone, so put control into the end user's hands and take down consumption, but that would actually be bad for their business. I accept that, but they have to decide, do they want to do, are they in business just for profit and never mind the people and the planet, or are they in business to create a sustainable environment? From where I'm sitting, the sustainable environment is actually losing because of the DC operations. I would like to see them, for instance, carry out and publish the findings of a water footprint assessment for their whole operation for the year. And then next year, do it again. Let's see how we're doing. Are we improving? And if not, why not? Because we should be. We've already heard that the whole region is running out of water. I note George's points from the earlier session. There were a couple. I notice George's mention of global water requirements, but we're in the Middle East. Water is in seriously short supply here. Refrigerants we touched on. Water is a refrigerant. More people will die from drowning this year than they will from inhaling refrigerants, or the more common refrigerants. So water is a critical issue for district cooling providers, and I don't really think they're taking it seriously enough. Taking it seriously, yes. Can they do better? I'm convinced they can. Francois mentioned that the improvements in efficiencies on standalone equipment will drive the district cooling providers to become more efficient and more effective, perhaps. But why do we have to wait to push an industry to be more environmentally responsible? They should be driving and taking the lead themselves and saving water.
They won't, because it's a business, and so
Exactly,
they make more money.
Yeah.
But from your perspective, it's not directly related to water and its availability, but indirectly it's related because you're billed on a square metre basis, and there's no incentive for you to reduce because your rate will never change.
Yeah, but and it does affect the water consumption. It would affect my own personal bill. It would reduce the power demand at the district cooling side. It would take down the water consumption at the district cooling side. Zakir mentioned Discovery Gardens this morning, maybe 250 facilities. If they all reduce their consumption, the effect could be quite dramatic on the power consumption at the plant and the water consumption. It might also be dramatic on Palm District Cooling's revenues. And that's where the problem lies.
No, but that's also on the standalone. If we use adiabatic cooling on air-cooled chillers, we can reduce power consumption on air-cooled chillers by 20%. So, as long as we make maximum use of the water, that's what we can do.
But I mean, we've heard again this morning that the VRV systems, I think, was it 1.2 or 1.25 kilowatts per ton that we can get out of them. There are district cooling plants that probably struggle to achieve that efficiency. And we focus so much on kilowatts per ton that we actually lose sight of the water.
Okay. Thank you very much. We live in a desert. It's hot and there's no water, so it's all a challenge. Mr. George?
We have around 1 million 1 million ton of cooling, district cooling in operation as actual peak load at max. And for such, our peak consumption of water, if we are using fresh water, is 94,000 cubic meter per day out of the 3.33 million consumed by the country approximately, which amount to 3% of the total water produced. Against that, we are saving around 700 megawatt of power out of the estimated 12,000 megawatt peak comes to 6% of the country energy. So district cooling is contributing to reduce 6% of the peak power demand. Now, 700,000 kilowatt will cost a fortune. In fact, between generation and distribution, the cost per kilowatt exceeds 6,000 dirham. So when you talk 700 times 6, you are talking about a saving of 4.2 billion dirham, while producing around, let's say, 100,000 cubic meter a day. The cost is around 5,000, which come to 500 million dirham. So you can see from capital perspective, the saving on the country capital infrastructure is phenomenal when we shift from air cooled to water cooled.
I appreciate that, George, but we can live without electricity. Ultimately, we're not going to get. We won't last long.
This is a wrong
water.
perception. The electrification of the world is progressing at phenomenal rate, and we are here when we are consuming the highest amount of water per capita in the world in a desert, and as they said, 70 or 80% is gone to irrigation, and really attacking the district cooling, which take only 3% of that water. We should always, in terms of conservation, we always start by the biggest culprit.
But why aren't they doing something to make that 2.9%, George?
We are, and we are shifting to DSE.
In the designs that are coming online. What about the operations?
The actual operation.
They've got to keep trying to reduce their water consumption.
I'll tell you that in 3 years down the line, 50% of the district cooling in UAE will be using TSE water that otherwise has to be gone to the sea.
Yes, but and again, that comes back to the point that Francois made earlier. The pressure was put on the district cooling providers for this. I can remember, as you can, I'm sure, sitting in the conferences a couple of years ago, listening to district cooling providers say they had the designs on the table. They were going ahead, and the government said use TSE. My point is the industry should be acting in an environmentally responsible and sustainable manner, and actually working forward themselves, not being pushed.
Look, I think we are evil by nature, and we need regulation to fix us up. Thermal storage reduced 15% capital cost and 3% operating cost. So it's no-brainer for any district cooling to use it. Thermal insulation save actually massive capital cost per square meter, save you more than 100 dirham per square meter because you have less AC system and smaller electrical system. That saving is much more than the 20 dirham extra you pay for insulating the wall. And yet without law, we only had 1% of people insulating their homes. Similarly, thermal storage in the industry was not used more than 30% of the cases.
But are you going to wait for the industry to
the DSE water, if you use DSE water, you would save 5 fills in operation per ton hour out of your total cost of 45. So I always said to the district cooling industry, did you really need regulation to tell you to save? This is a no-brainer. It something that save capital cost and operating cost. Wouldn't you be crazy not to implement it? Of course you would.
George, all your arguments are centered around capital cost and money. I'm talking about water and the environment.
In the environment, I told you that even if you use potable water, you have 0.93 average on district cooling kilowatt per ton, plus 0.05 kilowatt to produce that water. That's still much less than the 1.6 kilowatt per ton required for air cooling.
But I'm talking about the operational water consumption.
Now this is the operational water consumption
of the district cooling.
9 liter per ton hour.
Yeah,
what I'm talking, I'm not talking about the weather.
You keep going back to kilowatts, George. Kilowatts, and
kilowatt is CO2 emission.
Yes, kilowatts and dirhams. I'm talking about cubic meters of water that the country doesn't have.
But this is desalinating. And if the country doesn't have, it should start by conserving the irrigation.
And why doesn't the district cooling fraternity reduce its...
Look, I will tell you, an intelligent adversary to us, which is Israel. They had shortage of water, and they said we can either use it in irrigation to produce fruits and vegetables and trees, or we can use it in industry. They look at the impact on GDP and said they prioritize the industry because that is much more, it has much bigger impact on the GDP. Similarly, if I tell you that you want to conserve water to water that forest facing Antut area, no, we have priority.
Let's focus, George, and focus the witness. Let's just, it's very clear what you want to achieve here. Water in standalone or water in district cooling. How much are we consuming water in both?
It is the same.
CapEx and operational wise, and it's, you know, and let's move on to the next witness.
His point, Your Honor, is that irrespective whether standalone or district cooling, the sheer point of using water in a country shortage of water, he's objecting to, in standalone or in district cooling.
Yeah, I'm aware what he's saying, but I'm saying let's just focus the debate back into what we hope from.
So, I mean, weather used, we prove the point that water cooled is more environmentally friendly than air cooled by nature. And in the worst scenario, even if you use potable water, it's still more environmentally friendly, and the industry is going toward TSE water that is being thrown, or seawater, or other alternative that will make it even more friendly.
And a high efficiency VRV as a standalone against being provided by a district cooling company in terms of water consumption for that building?
The VRV provide efficiency when it's applied, but compared to even their best system, compressor kilowatt per ton, because it's small, it consumes around 0.8 kilowatt per ton compared to...
But we're talking about water, George.
No, I'm saying water-cooled VRV. Air-cooled VRV, they claim their average is 1 kilowatt for the compressor only.
1 to 8 in overall. Yeah. Can I add something, Your Honor? 2 seconds. Alan, you have your experience in doing a lot of energy modeling and overall. It gives you a little bit of flavor how our current cooling plants are operated. Do you believe, based on your experience, that the current district cooling plant are operating at the optimal efficiency, energy first?
Yeah. 5 minutes. So it's almost 4 now. So we say like we will meet back here at 10 past 4. Yeah? Okay. 10 past 4 for the closing remarks. Yeah?
Is there any commercial points and time? No?
You know, this we were disappointed by the amount of crowd, but we will be recompensated by the publication in the magazine, and they are starting a TV coverage.
George,
by Vicente
George,
also.
it's not the quantity, it's the quality that matters.
True.
Okay. Shall we reconvene, please?
In the last 2 days, we managed to demonstrate the economic and environmental viability of district cooling. And we tried to broaden the case to say district cooling is not an electric chiller and cooling tower. We combine to it thermal storage, cogeneration, trigeneration, geothermal, and renewable energy. And we demonstrated that there is no city in the world that will go in the future towards sustainability without incorporating district energy as a basic part of its infrastructure, whether that is using combined to lake cooling, deep sea cooling, geothermal energy, renewable energy, traditional energy, cogeneration, efficiency. So we will tackle two fronts always via district cooling, which is incorporating renewable energy and incorporating high efficiency for systems, and we're gonna see big development, and the large centralization of plant will give us much better management of refrigerant, of water quality, of control, of measurement, of operation. The economy of scale by itself allow us to hire better consultants, hire better contractor, hire better operator, because these are working on large systems, and that will help improve the industry tremendously. I leave the rest to Mike.
No pressure.
I'll be short. I think the number one thing we want to look at is, we've heard a lot about standalone being able to be put anywhere where district cooling is limited. But on the other hand, when you look at where those standalone systems are and who's operating those systems, who's taking care of them. I live in a building where there's continuous maintenance going on. I hear hammers going and saws and different devices out there. But at times, my building is not being cooled the way it should be. Move over to district cooling. District cooling, it's an organized group with a structure. As George said, it's big enough that they can spend the money to have sometimes a little better people working on those things. But also, they have a mandate, if you will. Number one, the way they make money is by being efficient. So they have to try to find ways to reduce water usage, reduce energy usage, things of that nature. They don't want to inject chemicals unless they have to. They're limited by how much water they can retain inside the plant, because they can only send out so much dirty water to the waste people. They set a limit. If they would raise their limit by 10%, we could use 10% less water. Okay, so they're only restricted by some of the things that are put toward them. But in the end, they are working to have an efficient system. I don't know the exact numbers, okay, but a 30,000 ton plant in district cooling, if it saves the amount of energy that we believe it does, ends up with 1.75 million kilograms of CO2 per year that it's actually of carbon dioxide, that is not being put up into the atmosphere. And I don't know how many trees that is, whether it's 4 million, 45 million, or some number, but it's very large. Okay. Okay, what's that number? Okay, so in the end, we're talking about the environment as a whole, not just one item, not just two items. When we look at a global community, standalone systems, there are times we can't do anything else. But as we start looking at a global community, what we got to be looking at is how can we best utilize our water, the resources that we have, to try to provide the life and the comfort for that life that we're trying to do. And that's why we're here. That's why the discussion. And we hope that through the day, go ahead.
Just quick summary as contribution to the standalone system with the cooling system.
in terms of your answering your question in terms of carbon dioxide, for 44,000 pounds standalone plant and compared to the equivalent of 35,000 pounds.
Sorry, Mike, can you please pass him the microphone?
I have made some quick calculations, and then this is the summary. I can show it across to the panel members. A quick comparison of a standalone consuming about 44,000 tons, equivalent of 35,000 tons when you apply the diversity on the district cooling. And using the industry figures, there is an annual reduction of about 195,305 metric tons of carbon dioxide, which is equivalent to reducing about 48,000 cars, each traveling 20,000 kilometers in a year. Yeah. So the data for this, which of course has been taken from the industry, basically.
Okay, thank you very much. Thank you. Standalone systems are ready for their closing remarks.
Yes, thank you. Yeah.
Please.
As we're going after these gentlemen, it gives us a little bit of an advantage. George was saying that if the industry improves, there will be a chance to employ better contractors. So we assume by that statement that the contractors that they've used to date have been of a poor quality and haven't delivered the product that they should have been. That's why they run inefficiently. That's why the tariffs are high and they don't work properly.
Don't put word in my mouth. I said because of the size of district cooling, they can use better contractors than standalone.
And also to continue on with Mike, he says was that they were going to make money. Now, the purpose of district cooling is really they're putting it in for the end user. It's a product. You're selling it to the end user. Okay, so it's the end user you should be giving benefits to in terms of what you're delivering. You deliver it cheaper. You deliver it better. At the moment, they're failing in that. Okay, there is no legislation to govern them. There is no buy-in from the government in order to get better tariffs. They haven't even spoken to the government to try and get this. There is no organisation to pull them all together. So at the moment, if they can do that, then it will work. And we'll all be for district cooling if there is benefits to all. As Salah says, it is a win-win situation. At the moment, it isn't. If they can do that, then for sure we won't be having this discussion today because it will go towards district cooling. But they haven't done it, so that's why we are here. So from our perspective, from the standalone perspective, standalone it's self-sufficient. We control our own destiny. We can manage it ourselves. In terms of water, we can generate our own water, as we mentioned earlier. In terms of energy, if someone's charging me 25 fils for a tonne of cooling, for 25 fils I can buy 1.6 kilowatts of electricity. So as long as my COP is not less than 2.1, I can produce cooling on site for the same cost. If I use water for my air-cooled chillers, even air-cooled chillers becomes viable because I can reduce the energy consumption on site. The benefit of standalone is that we control our own destiny. That's the main thing. It gives a choice. District cooling is obviously, or quite often I should say, mandated upon the end user, and so they have no choice but to use it and whatever conditions are imposed upon them by the district cooling providers. So that's my closing statement at the moment, and I'll hand over to Salah.
Thank you. I guess on one word, as we said in the beginning, we wish that the 10% of the market share on the district cooling is well optimized. We understand current loop, there is glitches on it, and the district cooling industry needs to remove that glitches and improve it. It's not only on the district cooling provider, but it's a regulation, etc. That's why for the 90% remaining, it's very important to go in an efficient system. Prashant gave us some ideas. If you compare a district cooling system against an inefficient system, of course you can convince anyone. you gotta compare an efficient system with an efficient system. Standalone with district cooling. Inefficient system, we cannot, refer to that, and we understand. And the industry now, there is a lot of standalone inefficient system, but also there is
number of district cooling plants are not delivering the promises, are not making the end user happy, are not giving the choice. And this is very important. When we impose something, it's like doing something on the communist. Imposing it, and you don't have the free of to move on it. I will have to pay for it. Sometimes I'm happy, some not unhappy. That's why we need to find a way that the industry will grow and the free market and self-regulatory and making it a win-win situation. That's basically, that's why we think for the 90% of the market share, a new philosophy need to there from the beginning, from the concept to the end, the facility management, taking on consideration the energy efficiency aspect, the water scarcity and availability, the overall emission to the system, global warming, ozone depletion, and everything. Thank you so much.
Thank you very much, both. I believe the jury will need some time to maybe deliberate the final remarks. And if I can suggest like 15 minutes coffee break, I will be back here at 4:45 to listen to the jury, and then we'll be closing by 5:50. Thank you. Welcome back, everybody. I hope you are happy and refreshed, and just like us, can't wait to hear the verdict. So, members of the jury, have you reached the verdict yet?
Yes, Your Honor, we have. We have our observations and recommendations as the jurors. I think what we'll do first is we have put down our notes here, so if you would like to read them, we can circulate that later on. But we'll just try to make some general observations. The first set is, I think we need to really congratulate Climate Control for putting together a wonderful and very innovative program, and I think they do deserve a round of applause, particularly Surinder and his team. I think in my career of 15 years, I'm seeing for the first time an event like this in the engineering sector. And I think this is something that this region needs, and this kind of forum and innovative way of addressing this is wonderful. So long as we have not made permanent enemies here, I think we are fine. The second observation that we'd like to make as the jury is, we saw the four gentlemen here. Really thank God you are not lawyers, because you would have really lost your cases. We really genuinely hope that you are far better engineers than you were lawyers in the last 2 days. And I believe I think with the very fact that you're sitting there is testament to the fact that you are good in your field and you are the leading specialist in that, fighting for your cases. The third observation is that I don't know how many witnesses would agree to this, but we do not believe that there was any clear winner as such. I think there are cases for standalone and there are cases for district cooling. It's a matter of horses for courses. So as we said, if you're a building in the middle of the desert, you're not going to put district cooling. You might be innovative and put the plant in Abu Dhabi and run a several 100-kilometer pipe of chill water. But I think horses for courses is the right way to go, and which is, I think, is happening right now in this part of the world. The final observation before we go into the specific recommendations that we had on the 6 topics is that we believe as a jury that the discussion was very focused on UAE. We were very obsessed with the fact that we are in Dubai and Abu Dhabi and the UAE, and therefore we did not really discuss it at a global level, district cooling. And district cooling, I think, we believe is a far more global subject than just limited to the UAE. There are many other regions. So I think that is something that we need to really address perhaps going forward. Now what we have done as the jury is that we have obviously put down our notes together. We had one colleague yesterday who's not here today. In fact, he went back and he sent us by email, which we have printed out. And so there's a lot of effort that has gone in terms of really putting down our observations. I think the witnesses also did a fantastic job in terms of being grilled by that. And they responded pretty well in a positive manner. So thank the witnesses as well for this. Now going forward, to summarize, there were 6 topics that were highlighted. Many times the discussions went a little out of focus, but that's fine, especially when you have so many people sitting in the room, it happens. What we have done is we have listed down one or two recommendations / observations on each of those topics, having heard the debates. So we'll start with the first one related to occupancy profile and cooling approaches. Again, just a caveat here, just because we are the jury does not mean we are the most knowledgeable people. You are the most knowledgeable people there. We are just making observations from what we heard and what we understood. So in terms of occupancy profile cooling approaches, number one recommendation or observation is that load optimization of buildings should be made mandatory. An appropriate system application should be determined on a project-by-project basis. So you do not have a generic concept that this is what this project should have standalone or this project should have district cooling. At the same time, load optimization. We are not talking of load calculation, we are talking of load optimization. And there are many different ways of doing that, including passive design techniques, which are very catching up very well in this part of the world as well. Second, the DC service providers, as of today, it is our understanding that they are not really concerned about the calculations that have gone in to design or come up with your tonnage requirement. They clearly are very open to just receiving your requirement and giving you that or signing a contract on that. This is something that we have repeatedly approached our DC service provider, but we have not received positive response. We believe as a jury that DC service providers as well as third parties should be involved in load determination as well, so that the whole industry benefits better. This is something that, George, you mentioned specifically that you recommend to your clients that don't go by what you are asking for, maybe you need less. This is something that should be made standard across the whole district cooling system. Number two, delivering on promises. We were a little confused on that. Timing perspective wise, we felt that both the systems are okay in terms of delivering the cooling requirements on time. There are challenges with standalone, there are challenges with district cooling. We do understand that district cooling today provides temporary chiller plants, because obviously unless they have certain minimum load capacity, they are not going to be able to put up the permanent plants. So long as the district cooling companies are providing the cooling on time, there's no issue with that. But today we have cases in Dubai or in UAE, let me say, where we design a project or we master plan a community based on the fact that there will be district cooling service providing to the buildings. The buildings do not factor in design for chillers and associated auxiliaries. So they just design for ETS rooms. And at the end, when the building is up and ready to be commissioned, the district cooling service provider comes in and says, sorry, this is something that I can't do. So we have projects where we actually rent chillers on our own and we are cooling the building like that. So this is something that is very key to the credibility of the district cooling industry. There needs to be delivery, be it permanent or temporary plan, doesn't really matter so long as the cooling is provided. Key promises. Some of the key promises, rather than key promises, the jury felt that these are more expectations from the end users. We had listed 5 based on the discussion that we had. Number 1 is efficient energy consumption, which is again an issue that we got into details with. Number 2, reduce noise pollution. That is another expectation of the end user. Environment friendly and sustainability. I believe, we believe that end user would be very happy to go for district cooling if the end user is given the confidence that yes, by going district cooling, you're actually reducing your carbon footprint as well. Cost effectiveness, which is something that we will address later in the 4th section, and delivering on time. Now, we are not specifically stating here that one industry is better than the other on this. All we are saying is that these are the expectations of the end users, and this is something that both the industries need to be mindful of in order to be able to establish their credibility and success. The third issue was financing. Again, this was to the best of our understanding as the jury that this is financing of district cooling projects. I mean, technically, we are still getting to grips with the district cooling in this part of the world. Okay, financing is another subject which is, we believe, is still at the nascent stage. Our understanding based on the debate is that the district cooling industry is currently facing financial issues aggravated by the economic downturn. That may or may not be correct, but that's the impression that we received. Lack of trust between various stakeholders is adversely affecting the situation. By stakeholders, we mean directly from the guys who are setting up the plans to the end users. Now, second recommendation that we would make given this situation is that the DC industry should put up proper business case to banks and end users to win their confidence and resolve financial problems. We have seen this in sustainability industry as well. The banks do not have that line of business. So perhaps this is something that needs to be worked together with the financial institutions. Financing is not an issue with the standalone site so long as the developer has the money, because that gets pretty much covered by the financing of the entire project. So that's the observation on financing. Number 4, costs. We saw a lot of debate on cost comparison today between district cooling and standalone. The jury believes that the cost comparison needs to be carried out in a more scientific manner and should be comprehensive to reflect life cycle cost and charges. And we picked on the gentleman who did all the hard work of doing cost comparison, that, okay, you did not do this, you did not do that. We forgot the fact that he had done actually 80% to 90% of the work, but that's life, isn't it? Nobody sees the good that you do, they only pick faults on what you have not done. So I think that's something that is in the interest of both parties, and therefore both parties should get together and do the scientific analysis with all the pie charts and histograms and all that, and then prove to people. Which leads to the second point, transparency, to ensure that existing perception among end users is that the cost comparison that we debated today, each and every item, each and every component of that, be it servicing, capital expenditure, be it offsetting the fact that I don't need to add so much kilowatt connection to my building, or that I can free up so much space because I am not putting my own chillers, etc., need to be summarized and need to be opened up to the end users. Sometimes in our business we believe the more the customer knows, the better it is for us. Of course, it works the other way around as well many times. So that's something that the jury strongly, this is one point that the jury strongly felt about, given the nature of the debate. Number 5, environment, health and safety. I think it was pretty much a case, we did not even have to debate on it. I think the reaction of the standalone gentleman there told us all that district cooling is more environment friendly than standalone on a global basis, yes, but there are on a standalone and specific case-to-case basis that might differ. But we believe that the district cooling in an all-round manner, overall context of energy savings and water usage, etc., is more environment friendly. However, the other message that came across strongly is that standardized regulations today are not available on HSE for both the sides of the industry. That is something that needs to be developed. Many times we leave it to the government organizations. I think there was a gentleman here from Abu Dhabi municipality. That we are waiting for them. It sometimes helps for the industry to create or draft out these kind of standards and actually present it to the government and the various authorities. And typically, many industries in the world, in other countries, work that way, and therefore that's why they create industry lobbies, where the industries actually submit to the government what they want clearly in writing, and then the task of the government then gets easier. All they need to do is they need to review that and maybe appoint a panel of experts to go through that and finalize it. So that's something that both the industry side could look at. Number 6, and the final point, is water and availability. Yes, I believe there is a consensus that scarcity of potable water is there in the region. However, we also believe that there is adequate amount of TSE water available, which is today not being utilized properly. And that is something that, again, both the advocates came out strongly saying that both of them can utilize TSE water in the most effective way. So that's the general and specific recommendations and observations from the jury. I believe my colleague, one of them, had some closing out or general observations on the overall thing, and I'll pass it on to my friend here.
I should thank Climate Control for giving us this opportunity as an end user to participate in this debate. We, the jurors, collectively feel that the district cooling, provided it is proved to be the sustainable cooling service provision, it should be encouraged. But unfortunately, in this region, as it was rightly put forward by the advocates of district cooling, it's only 10% of the demand is being covered by the district cooling. The main reason would be that there is no proper legislation, there is lack of transparency, there is mistrust between various stakeholders, and the end users didn't get the full confidence in the service providers that they are being charged the right price and that the end users are paying the cost-effective and right price to the services being provided. So if all these problems are properly addressed, probably in the near future there is a bright chance for having the district cooling industry survive in this part of the world. Having said that, it's not the district cooling industry, it is the sustainable and cost effectiveness that drives the district cooling industry should be promoted further. Having said that, there are case by case that determines whether we should go for the standalone or the district cooling, and we are not passing any conclusion on which one is of higher or superiority. It's based on the sustainability and cost effectiveness only. We think that the district cooling should be further taken up further through the legislations and the industry transparency. And I once again thank you all for the opportunities given to us, and I pass it back to the judge. Thank you, ma'am.
Thank you. Thank you very much for these comments that are very enlightening, and I think it sums everything. I can see George is dying to have a comment, but you know, I don't think I'm going to give you the stand. Unless it's very short. Okay. Okay, thank you very much. We have with Dr. Ghalib and myself, we have just a few summary comments. It's more or less along the lines of the juror, but if you allow me a few minutes, I will just go through them. I second everybody on thanking the organizers, again, on behalf of Dr. Ghalib and myself and the organizer, and I would like to thank you all for accepting to take part of this and being engaged with us for the last 2 days. It has been very constructive. It's enriched all our experiences, and the subject has been handled extremely thoroughly by the two parties and the witnesses that were involved. We can see that the conclusion that we all reached can, it does have a potential to have an impact domestically and internationally. And I guess, at the end, for the will of all the humanity, because this is what we are all in the business of. We just need to take care of our planet. After listening to all of you for the last 2 days and discussions with between Dr. Ghalib and myself and with the juror, these are our recommendations. There is, and I agree, there is always going to be demand, and there is a huge room and need for all types of air conditioning systems, and there is no debate about that. But for each case, and on a case-by-case basis, and this is what we have been calling for, there should be a full and detailed study that need to be conducted, taking into consideration the full life cycle cost of all the choices that are around the table, including the new technologies that appears. It is your responsibility, the industry responsibility, the leaders, and again, with help of media, to raise awareness on the importance of expanding all these concerns to go beyond personal concerns and benefits and include the country's concerns, include the global concerns for climate change and for sustainability issues, and make sure that we are doing our part to protect our national resources for generations to come. Consultants and contractors need also come up with recommendations to the concerned authorities to apply standards. It has been very clear through the debate that there is a need for standards, and we should take the initiative as consultants, as contractors, to help, to support the authorities to draft these standards, to apply them. Maybe to help them with suggesting on incentives, on penalties that can lead to higher industry standards, while again having balance between responsibilities and interest for all parties involved. Again, I repeat, there will be always a demand for all types of air conditioning systems, and our target should be the use of the best technology and efficiency of each the type of air conditioning systems, rather than simply just comparing one system to another or one type to another, when the best of them is not feasible to implement due to any valid reason, whether technology or commercial or economical. For just an example, for highly populated development projects, maybe it's always advantageous to integrate district cooling with other utilities, such as localized power generation, utilities of waste heat, TSE, as we said, use of renewable energy, geothermal maybe, to boost efficiency and achieve higher degree of sustainability. It is also advisable, if standalone systems prove to be the best choice, we need to, through a feasibility study, should be always a consideration of utilization of solar energy, geothermal applications, and other more sustainable solutions. Maybe some of these recommendations will be considered to be costly under the prevailing conditions. They may not be feasible financially when all the cost is shouldered on one party, developer, service provider, and the client and user, or whatever, or tenants. It is important that we share the cost in a fair and just manner between the parties involved in accordance with the benefits each party shall enjoy. And again, this is an area for exploration and a way that maybe we can see how we can develop a mechanism to take it forward. On a project level, developers, service providers, contractor, manufacturers, suppliers, and end-user relationship is considered definitely to be dynamic, and it will correct and balance itself in a free and transparent market according to the demand and availability, again controlled by both ethics and rules. On country level, the public utility budgets and expenditure is directly affected by the efficiency of these technologies. By the efficiency of the technologies used in these projects. And in order to minimize and control such expenditure, a set of rules and standards, including incentives and penalties, needs to be implemented. Hence, there is a great area here for collaboration between everybody. On a global level, we all should work together to contribute to the well-being of mankind, influence the protocols and standards, and not wait to be influenced by them. And again, for that sake, I strongly recommend that CBI, with your participation and contribution, continue with such innovative summits. It will be my pleasure, and I'm sure Dr. Ghalib as well join me in this, to be with you again in future summits. And finally, I wish success to all of you and for all the efforts for the prosperity of this country. Thank you all. It is such a pleasure to be here today. I think it's fair to give you the last...
Silver sponsor, Tekem and Kamstrup, Ian Cube, who made obviously this event possible. I suggest we give them a big round of applause, if we can. Thank you very much. I would obviously like to thank Dr. Nawal. We were honored to have you in our presence. All of you are participants, witnesses, jury members, and advocates for a tremendous job. As George pointed out, the proceedings of this session will be obviously printed in the Climate Control Middle East magazine, and it will be also made available on CCTV, which is Climate Control Television, on our website, which is climatecontrolme.com. So please do watch out for that. And at last but not least, I am also delighted to announce that the long-awaited Climate Control Awards will finally take place in December 2011, rewarding obviously the best practices and best players in the region. And the theme for the awards will be winning in testing times, so a very interesting topic indeed. Faisal Jassim is already announced as our bronze sponsor for the event. We did our first test event, if you will, with the H2O Awards last year at the Atlantis Hotel. It went very, very well. So we do look forward again to a very successful and innovative event. Congratulations also, at last but not least, to the organizing team who clearly outperformed on this occasion. Surrender, obviously, Deep and Monesh. I think we can also give them a big round of applause, if you will. So many thanks again to all of you, and we look forward to seeing you again very soon at one of our events. Thank you very much. Bye-bye.
At the end, they told us we are bad lawyers, so we are resigning from the task.